Yeah. So I hope this screen is visible now. So the first question has been asked by Mr. Animesh Mahato. He's from Kolkata and he's a working professional. So his queries, what I will do is I'll just copy them and maybe paste it somewhere else and try to take the queries over there. Okay, so let's see what he's trying to ask. Okay, so his query is in pumping station building. It's a sump, half portion is below ground, and applied modulus of subgrade reaction on its sump basement portion. Okay, so I think what he's saying, let's say this is a pump room, and then they have a sump like this. Sump means it's a pit, that's why I have shown it like this. And applied modulus of subgrade reaction on its sump basement portion. Okay, so this is what I can understand, that this is ground level and then this is the sump and then this is the wall for the sump and this becomes the basement draft for the sump. So while analyzing in StatPro and checked movements generated in floor slab of pump house and basement wall creating large movements. Same model while I have checked by creating fixed support below RCC wall foundation and interior column, also an omitted draft below sump. Then checking for wall and floor beam moments result are very less than before. Should I design this superstructure and substructure differently because TAD can't give correct results while monolithic designing? I'm not sure what his question exactly is. It's becoming difficult to understand from the language he has written. It's confusing. So I guess, Mr. Animesh, if you could send some images or show it in a sketch. If you're watching this session live, just send me a sketch, supporting sketch, so that that can be referred and then we can discuss. Okay. Right now, I'm not able to understand this question properly. All right. Then his next question is, when should we use flexible support and rigid support at slab base? And is there any IS code mentioning these joint? Okay, so I think he's saying when to use flexible support and when to use rigid support. See, when you are having a slab base, and especially if you are designing a slab which is resting on ground or which is resting on some compacted earth, so you don't have to. So let's say this is your slab and it is resting on some compacted fill. So you're not supposed to, ideally, if you are doing this slab, you are not supposed to provide any fixed support or flexible support. What you need to do actually is you should provide soil springs. Okay, so it's a spring support where the stiffness offered by this compacted soil fill will depend on the compaction of this earth surface. Okay, so now how to find out this stiffness, how to find out the spring stiffness of this soil. So to find out the spring stiffness, now there are some documents uh, that you could refer to. There is a document named as TR34, I think, which is a document on industrial floors. Let me see if I can quickly find it. Mm, Industrial flooring, yeah. So it's a British document. I had also taken it from somebody else, Mr. Rahul Brijpuria, engineer. He had given me this document because they were using this in one of their projects. So let me just show that document to you, maybe. So, for example, if you are doing an industrial flooring, yeah. So this industrial ground floor, a guide to design and construction. So this is a British standard, and the Indian document, the SP, I think it is some special publication. So that is also based on the same British standard. And over here, if you see, they have given the design principles for such slabs on grades, what to do, structural design of ground supported slabs. So it is more like, this design is more like a pavement. If you can recall the rigid pavement design approach that we used to adopt, maybe you might have learnt it in your BE Tech. So that same approach is given for industrial floorings also. So the entire game, or the entire principle of design, will depend on the nature of compaction that you are able to achieve for your earth below. So depending on that, usually, even if you refer some IRC codes, they also follow a similar methodology where they say that you find out the CBR value, okay, California bearing ratio of the compacted soil. From this CBR, then they give a relationship between the CBR and the K value, or the spring stiffness that you can adopt, okay, or the subgrade modulus, so to say. Spring stiffness or subgrade modulus. So depending on the CBR, usually we will get the K. Once we will get this K value, then you can assign this K value at your slab level, and then for your loading, you will get the moments and shears in your slab. Accordingly, you will find out the reinforcement, and you will do the various checkings. So this is how the industrial floors or slabs on grades should ideally be done. All right. Uh, any IS code? I am right now forgetting the name of the IS code which covers industrial floors or slabs on grades. But as I told you, you can search for this TR34 document. You will get it. And the Indian code also follows the same approach that has been mentioned over here. And as I said, I must thank engineer Rahul Brijpuria for this, because he had sent me this TR34 document. So you can also get it freely from the internet. Okay. All right. So this was what Mr. Animesh was asking. Then let us go back to the next question that has been asked, and I'll just stop sharing and present. Okay, yes. So next question is by Mr. Vineet Kabadi from Pune. He is a working professional. Please explain LX, LY, and LZ parameters for beams and columns. So LX, LY, LZ are the effective length parameters. Usually, you need to define these parameters in STAT, because ETABS has a good, what should I say, has a good computing power, that ETABS is able to calculate these effective length factors quite well. So in STAD, you have to give them because STAD does not or is not able to calculate it quite well. So if I was to take steel, if I were to tell you about steel, then these LX, LY, LZ parameters are the effective length parameters for calculation of compressive strength. So you need to calculate the effective length. Okay, you need the effective length factors. Why you need the effective length? Because you want to calculate the Euler's buckling. So for that you need the effective length. So these LY LZ factors help you to calculate that particular effective length for compression capacity calculations. Okay, this is different from the sway effects. So sway effects are different. Here I am mostly focusing on the uh, effects not associated with sway. The effects related to the end conditions between the columns and beams. So Ly, Lz are the effective length factors which are to be provided to STAD, defined as parameters for the compression capacity calculation. Lx parameter is the effective length factor that is used for the effective length factor for the lateral torsional buckling, LTB. And where will this be used? This will be used for calculating the compression capacity, flexural capacity of your section. So LY/LZ will be the effective length factor used for compression capacity calculation. Lx will be the effective length factor used for lateral torsional buckling length calculation. Okay, so these are these parameters, and it's very important that whenever you are doing any steel structure, especially in STAD, you should properly understand these factors and you should be able to assign these factors properly in your structural steel model. Otherwise there will be a lot of problems and issues. ETABS is able to intuitively do these calculations, but not STAD. So when you are using STAD, you have to be very careful with it. Okay. All right. So then the next question was asked by Mr. Mohammed Misbahul Haq from Patna, and he's saying, "How can I get rid of tag of fresher when no company is hiring freshers for job?" Very good. So this is what is known as a typical catch 22 situation. Catch 22 means where the solution to the problem is the problem itself. Okay, if there is such a situation where the solution to the problem is the problem itself, then it is called as a catch 22 situation. And what he is asking, how can I remove the freshers tag when no one is ready to give job to a fresher? So it's a typical catch 22 situation where the solution to the problem is the problem itself. That means the solution is the problem. That so if I wanted to give you another example for this, maybe let's say you enter into a room and it's completely dark. All right. Now, what is the solution to uh, get rid of that darkness? The solution is to turn on the light. But because it is so dark, you don't know where the light is. So the problem or the solution to the problem was the problem itself. So similarly, nobody is ready to give job to fresher because they say that you don't have enough experience. No one gives jobs to freshers because they are saying that you do not have experience. But then if you don't get experience, you will remain a fresher, isn't it? So someone has to give you a job, only then you will get experience. So this is a classic catch 22 situation. But when we in our office, when we call for interns or when young engineers join us, we usually prefer we usually prefer that engineers who join us don't have any experience. I think experience is overrated. Uh, I don't believe much in having experience. Uh, we always prefer inviting, or we always prefer to have freshers working for us. But yeah, that is a problem most of you will face, that no one is giving jobs to freshers, and because you don't get a job, you don't get experience, and you will always be counted as a fresher. Yeah, that is a problem. I agree. Solution to this can be maybe you do some internship somewhere. Uh, so maybe that can be a unpaid internship where you join someone, do some internship, or try to take some freelance projects from someone who is already in this field, and slowly build on your experience by that manner or in that way. Or you get associated with someone who will teach you, or who will train you or mentor you. Maybe that can be one of the solutions. Okay, but yeah, I do agree that it is a problem. Yes. Then Mr. Akash Babar, he is joining us from Sangli. And what is he saying? Let's see. So engineer Akash Babar from Sangli is a working professional. He is asking, okay, so he has couple of questions. Let me just copy them and try and take them one by one. So, okay, so he is saying which one gives better and accurate results for footings or rafts above 1000 mm depths in safe, thick or thin shell. I have tried till 2 meter, 2.5 meters, uh, and I had continued using the thin shell assignment. It gave me, I mean, acceptable results. Uh, Accuracy, you can try it by using it for a simple isolated footing, because in isolated footing you can do a quick cross check of what calculations or what results you expect through the software, and what analysis outputs you are able to calculate manually. So maybe for a small isolated footing you can check. But see, more than the thickness, it is also about the distance of supports. Okay, so if you, let's say you had a case where you had very closely spaced columns and thick raft. So you had closely spaced columns and you had thick raft like this. Now, if you give a thin shell element assignment, maybe the deep beam action or the strut action is not able to be accounted so well. Okay, or maybe because of the thin shell assignment, you are missing out on the in plane shear deformations, which are exhibited in a thick shell assignment. So thin shell may have problems, especially when the depth is large, and not only the depth is large, but the columns are also, or the support points are also quite close to each other. Otherwise, I would say thin shells perform quite well, and they have, I mean, what I could figure out that they are giving acceptable results. So I prefer to go with the thin shell assignment only. Okay. Then he is asking, next question is factor of 1.5 necessary to be included in the preset P delta analysis in ETABS for EQX and EQY? See, this IS 16700 has created confusion. Why? Because it has uh, I think for the first time it has given a load combination that has to be used for the P delta analysis. But the confusion is that it has in its clause mentioned, and let me just show you uh, which clause number is it. This one. I'll just share my screen. Yeah. So if you can see this uh, structural analysis 7.2 considerations, the load combination for initial analysis considering P delta effects shall be taken as this. Now, from where this combination comes, so this combination basically they have picked from the ASCE 7. So ASCE 7, it says that whichever load combination where you have dead loads and live loads and lateral loads combining together, you pick that load combination. So that's why this 1.2 dead factor has been mentioned. Now, what is the reason for this zero point 0.5 live load? Why not the full live load, or why not the 1.6 live load, or why not the uh, live load factor which is given in ASCE for combination with lateral loads? So the ASCE 7 itself gives this reasoning that why are we not taking the full live load? Because uh, live loads are variable, and during the P delta, or let's say when the lateral loads are acting, at that instant, maybe the full live load is not present. So, in order to take a more, what is the word I want to use? A more justified value of live load, they say that for most of the occupancies of live load, it is fair to assume a zero point 0.5 live load as the factor. Okay, you can refer to, I think, section 12. I was reading it just a little while ago. So I think the clause is 12.8.7 of ASC 722, and you can read the commentary for that particular clause. So there they are saying the reason behind. So I'm saying go to uh, ASCE 7 clause is 12.8.7. Go to commentary of this clause. So there they have given this logic that you combine all the gravity loads with the factors that are associated in a particular load combination where dead, live, lateral loads all are combined, and then you pick up this part. Okay. So, and therefore the reason for this 1.2 dead plus, and now why 0.5? So the reason I just mentioned that for all the general occupancies that you may get, this is an acceptable factor considering the possibility of live load reduction and considering the possibility of variation in live load. 0.5 is considered as a acceptable factor. So in P delta, technically there is no need to include this. Now the confusion Indian code has created 16700, that they have included the lateral load case also in this combination. That is not needed. See, the concept of P delta is that when your lateral loads are acting, the gravity loads which are already acting, what they will do is that they are already creating some displacement. Sorry, the lateral load, because they are creating some displacement, now they will be acted upon by this gravity load that was already present, leading to an additional moment of P into delta. That is the logic. So basically, we only need the gravity component. So this gravity component we need to apply on our member, which will result into additional moment when there is a lateral deformation due to some lateral load. Understood? So this should not have been there. What they should have written, they should not have written this, and they should have written that you only take this in the preset P delta option, only this, and then automatically the effect of this P acting will be seen in all the members for any lateral load, and then it will be included in all the load combinations also. Okay, so I think when the code, maybe in an amendment or in the next revision or something, they will remove this lateral load factor from this point number D. Is that clear? So you just apply in the preset P delta option, you just assign this. That's all. Okay, just do this. All right. His next question is semi-rigid diaphragm assignment for 10 thick grating checker plate correct? Yeah, I mean, whenever you have doubt, go for semi-rigid, unless otherwise you are sure that this particular floor system will behave as a rigid diaphragm in plane. It is always better to go for a semi-rigid assignment. Okay, no harm in going with a semi-rigid assignment. You should always go with semi-rigid assignment whenever you have confusion. All right. So these were his three questions. Then, if there are any questions from the live audience, they may put it in the comments. We are just about to finish the questions that were asked through the Google form, and then we can take up some live queries. So next question is from Sunil Kumar Jatav. He is joining from Howrah. He is a working professional, and what he is asking: how to determine the size of base plate? How to determine the size of base plate for stub column that starts from mid of beam flange? I mean, the concept remains the same. You need the loads, moments that are acting on your column at the column base, and as per the column loads, moments, you will be able to find out the base plate size. So the basic concept of base plate calculation won't change. Okay. Yeah. Then engineer Vikash, he's a working professional. Tutorial on industrial chimney design, concrete and steel. I think you in for this you can refer some good books which cover some advanced topics on RCC design. So whatever those books cover, usually in our practice also, we follow the same process. There's no change as such, if you ask me. So whatever are the standard process, uh, the same process you will use in your design offices also. So you can refer any good book. So I think Krishna Raju's book on advanced concrete structures, I think it has covered chimneys and other stack-like structures. You may do that. You may see that. And for steel chimneys, I think a book by Professor Variani does have steel chimneys included in it. And I think some other books must be there, though I can recall these names. So any good book you refer, you will find proper guidance and proper design steps, and the same steps usually we also follow in our design practice. All right. Okay. So I think these were the questions that were asked in the Google form. Now let us take some questions from the live comments. So Mr. Harish Acharya is asking how to model floating columns in ETABS. How to model means you have to model as per the geometry. I think your question is regarding whether to put pin I mean, whether to release the moments between the floating column and beam, or to consider it as a rigid junction. I think that is your question. So if this is my beam and this is column and this column is floating, what you want to ask, I guess, is the junction between this beam and column. So many engineers have this opinion that they may, or they ideally they would like to give this as a moment release, because they say that because of this moment release, the beam sizes that they get in design are lighter. Lighter means the beam needs to be designed for lesser moment, so the beam size is reduced. But in my opinion, you don't have the necessary, at least in RCC, you don't have the proper process to ensure that this junction will behave as a released connection. Many people or many documents that I've read, they do some reinforcement detailing like this, but I don't know. I mean, I'm not sure whether this will, how this will behave. If you do this detailing, you are still providing a sufficient length, and that is enough, that is a substantial length which will generate your yield level stresses in the bar, thereby thereby not allowing this junction to behave as a released junction. So I'm not sure uh, why they try to release the moment. In my opinion, you should treat it as it is. That means you treat it as a rigid junction and design the supporting beam for whatever moments are coming from your floating column. Okay. Yes. Mr. Arbaz Kazi is asking why semi-rigid diaphragms create more forces. See, because in rigid diaphragm, you're locking one degree of freedom out of. Okay, let me just finish this. So, Mr. Harish Acharya is asking no need to release, right? Yeah, in my opinion, it is not justified by the reinforcement detailing that you provide to release this junction between floating column and beam, especially in case of RCC column beam. See, if you had a steel floating column resting on a steel beam, or maybe a steel floating column on a RCC beam, it would have been easier for us to create a uh, moment release connection between column and beam. Okay, if let's say the column was steel, beam was RCC, or if both were steel, it would have been simpler for me, uh, and detailing wise also possible for me to have a released connection. But in case of RCC column and RCC transfer beam, I'm not sure how moment releases will work and how we can justify them by reinforcement detailing on site. Okay, so my one line answer will be don't give moment release. Yes, so Mr. Arbaz Kazi is asking why semi-rigid diaphragms create more forces as compared to rigid diaphragm. Because in rigid diaphragms, we are locking one of the degrees of freedom, that is out of plane degree of freedom. And in some cases where your slabs may have tendency for out of plane behavior, or where there might be substantial out of plane behavior due to which some additional forces might be generated, that thing is not displayed when you have rigid diaphragm assignment. Okay, so therefore you will see that when you give semi-rigid diaphragms, you see some additional forces that were not there when you had given it as a rigid assignment. Not only out of plane, even in plane will be a problem. So for example, uh, how do I give you example for this? Okay, so for example, let's say this is a slab in plan view. Okay, and there is an X bracing in this frame. All right. In plan, you will see it like this, but this is an X bracing in elevation. Now, what might happen if you had given it as a rigid diaphragm First of all, you had logged 1 degree of freedom, that is the out of plane. So all the points, there will be no out of plane behavior in them, and in plane also they are forced to move as if every point is trying to deform by a same magnitude. So because of this, you miss out on some forces that might have been created with a semi-rigid diaphragm. So what you can try is you can try to make a simple plan, provide X bracing over here in elevation, and assign it as a rigid diaphragm. You will not see forces, axial forces mainly, getting transferred in this X bracing. But when you will do a semi-rigid diaphragm, then because of that additional degree of freedom available, you will see the forces now getting transferred to X bracings also, especially for lateral loads I'm talking. So therefore, this thing happens, and that is why we need to be careful under which case we should assign the rigid diaphragm assignment to your slabs. Okay. Mr. Arbaz Kazi is asking, will I still be having a base plate in steel structure building if it is 40, 50 story tall? Won't the base plate size be too big? Yeah, it will be big. But then if you have a steel building, you have to terminate it at some location on some RCC element, right? So if you have a steel column in elevation I'm showing you, now whether it is a 40-story column or a 50-story column, finally you have to terminate it on some RCC element. Okay. So when you need to terminate it on some RCC element, there has to be some interface provided. So this interface between the RCC and steel is nothing but your base plate. So that will be the interface, and then of course you will provide all sorts of stiffener, etc., gusset. But main interface is your base plate. So it has you have to provide a base plate, whether you are a 10-story building or a 40-story building or whatever you are. Okay, clear? Yeah. And see, usually if you see, the base plate size is governed by the base plate size is usually governed by the bearing in concrete. All right. So the bearing strength in concrete is quite substantial. And if you are having a 40, 50 story tall building, the steel columns itself will have a quite large size. So you will see that the base plate, which is usually governed by bearing, the size of base plate in plan, will usually will usually have not a very large offset beyond the column face, steel column face. So what I mean to say is this offset, it will not happen that you need a 1000 offset for this base plate. Why? Because even this column size is quite large, and some maybe 200, 300 offset, and you are able to satisfy this in bearing. Okay. Yes. Yes, Mr. Animesh Mahato had asked the question earlier, which we were unable to clearly understand. He's asking, he's saying, shall we design some fall and base slab by using water pressure, earth pressure on wall, and applying water and uplift pressure on base slab in same model or in different model? Because when I have designed wall and slab in same model, it created unexpected moment at top. Uh, Unexpected moment. I think we still have the figure that he has shared. So this is his figure. Now he's saying that this has water pressure and earth pressure. Is that what you're saying? See, ideally, if you ask me, you should have everything modeled together if you want the appropriate behavior. Okay. So if you say, ask me if this is your raft that you're providing, and if this is the sump, and if it's a large sump, considering, see, 1.5 meter small plan area, it does not matter much. But let's say you have a large plan area. So if this was an elevator shaft, let's say for a building, I would have said you may do it independently, nothing, no problem. But if it's a large area, maybe, I mean, if your sump is large area, then it is better that you model everything together to get the correct picture. Okay. I am asking, shall we design some wall and base slab? No, same model. Do it in same model. Okay. Do it in same model. Yes. Okay, please. So anything else? Okay. So these were the questions that were asked on the Google form, and also the questions that were asked in the live comments. Are there any more questions? Okay, so there were no questions that we had received on email. So I think these were the questions for this week. Any more questions we have? Okay then. Oh, we have. Civil engineering software knowledge is asking, G plus 1 RCC design steel consumption is 2.7 kgs per square feet. Is this satisfactory? See, for this, you need to first see, I mean, one anyone cannot comment just by looking at G plus 1 RCC. You need to know the spans, you need to know the loadings, you need to know the column to column spacing. Okay, you need to know the plan area, you need to know the SBC. There are a lot of things which you need to know before giving or before discussing these types of thumb rules. So these thumb rules will work only for a normal, let's say, where you have a 10-11 feet beam spans, you have columns at every 12-13 feet, you are getting columns, and your footings is also on a medium soil, let's say 20 ton, 22, 25 ton per square meter SBC, then this much 2.7 kg per square feet consumption is possible, achievable. Okay. And for normal residential type of loading, let's say 2.5 kilonewton per square meter live load, normal floor finishes, normal brick walls or normal walls, then this type of consumption is possible, provided all these conditions are met. All right. Mr. Harish Acharya is asking, for complicated geometry in steel structures, like if I want to design stadium, which software is better as per your opinion? See, input output option wise, ETABS is better than STAT. For the help of modeling, if you have a complicated structure, you will have to do more jugaad work in ETABS to bring that complicated structure. Instead, it is easier to bring complicated structures through DXF. In ETABS, it can be slightly more challenging to bring these types of structures. But just let me see something. I'm just checking one thing in ETABS. Okay, yeah. So you are able to bring DXF file also quite well. But then load application for slant members, selection of slant members or selection of members that are not in your clan view, it can be slightly difficult in ETABS than STAD, I would say. But then because STAD has other issues related to your input output and other design issues, maybe I would still suggest ETABS is a better option. And if you want to stay in the CSI family and you have a irregular complicated structure, maybe SAP 2000 is the best solution. But then SAP 2000 does not have all the design features that ETABS has. All right. So in SAP 2000, maybe the design features are not so well developed as they are in ETABS. So then you will face problems on the design side when you want to do designing work, or even the preset options or some of the features that are easily available in ETABS. In SAP 2000, you have to work a lot for those simple options. So there are problems and difficulties associated with all the software. So let's say if you are able to do some work on your own, especially for design outputs and for some analysis inputs, maybe you can use that. Maybe you can use SAP 2000. Okay. So, for example, when they had designed this bird's nest in Beijing during the 2008 Olympics, they had used SAP 2000 for the bird's nest. Okay. Uh, yeah. I think that time ETABS also was not very well developed. That time you had the ETABS 9, I think. So ETABS was also not well developed at that time. Right. Okay, so Mr. Animesh has sent this image on WhatsApp, and this is his pump room. If you can see, it's a huge pump room, and then there is a sump, large sump. Okay, so in this case, he's asking, should I detach it? See, in this case, if I would, if I wanted to change my opinion, maybe you can have it detached, but then see, just carefully see to it how this connection between your pump room and sump is happening. Okay, so maybe you can develop a system where pump room and sump is totally not connected with each other. All right, or let's say you want to connect it as is your case over here. Maybe then it is better to model it together what you have done, because I can see some columns are going through the pump room slab roof, and some beams of your pump room floor are also the beams of some top slab. So maybe I think in this case it might be better to model it together. Okay, what you have done. Just hold on. Just give me a couple of minutes. I'll be back. Okay. Yes. So model it together, okay? All right. Civil engineering software knowledge is asking, my question is that in ETAP software, the bending moment in column is more in top floor, but ground floor column bending moment is less. Which moment is considered for design of footing? Of course, whatever footing, oh sorry, whatever moment you get at the base, where your footing is going to be at the base of the column, of course, that moment you will use for your design of footing. So, for example, this was my frame, building frame, and let's say these were all beams. And suppose you are getting your moment diagram, whatever you are getting, some moment diagram like this, okay. And suppose at the base, your moments are less, whatever are the moments. So, you will pick this moment for the footing design, okay. Axial load, of course, will be whatever is transferred at this level from the top. So this axial load plus the footing, the moment at the base. Good. Anything else? Okay. So I think uh, these were the questions that were asked for this week. We have taken up all the questions that were asked on your email. No, so there was no question on email today. So we have taken all the questions that were asked in the Google form and through the live comments. So I guess that is it then. See you next week with another Ask AuxEn Anything session. Yeah, have a good weekend. Bye bye.